Hey, hi guys, welcome to the last Crack Me video of this reverse engineering training. I'm gonna show you the solution of the Crack Me that we upload last week. So here is gonna be. So basically, this is how it is. So you got this Crack Me training 2. So if you open it on IDA or your favorite debugger, I'm gonna show you two ways. So first, well, of course, I think we were until here bypassing the check for is the barrel present, this one. So first, we're gonna check if the barrel present, and then on the last video we added a breakpoint, a conditional breakpoint, and then on this we set a condition that will always set the flag for the zero flag to 1. So when it checks, when it checks this, when it does the sham, if it's 0, that's the condition. It will always go here. The result of this sham is set from the function is debugger present. So that's a way of bypassing this condition. So in order not remember that in order not to reach this breakpoint, we can also set it to disable. So basically, the condition is there, but it's not enable the breakpoint. So it will go through it, but it will not break. That's something that we can do. So we can disable it or break it. So if we don't break it, if we don't break the execution, then it will not stop there. It will continue. Will come directly here. So that's what we are gonna do now. So this one is red, but is not is enabled, but it's not gonna break. And this one, this new breakpoint that I choose add, is enabled and it's gonna break here. So if we start this program, oops, sorry. I think for some reason Defender is is adding this fragment as a node to device. There you go. And let's choose disable different. I don't know why it's detecting this fragment. I don't really care. It's a virtual machine. The crappy I made the whole source code myself. So and you have the. I will also provide the source code if you don't trust the crappy the binary. You can also compile it yourself. The source is like this much. It's quite small. And actually, using X-rays, you can see the source code. Also, if you use Jira, you can decompile it using Jira. But anyway, let's go back to it. So if you happen to have the same issue, and always remember, guys, always when you do practice, it doesn't matter if you have the source code, you doesn't, or you have anything. You don't have to trust the practice, or you don't have to trust anything. You can always use a virtual machine. If you use a virtual machine that is isolated and not connected to any network, and isolated from the host, it should be fine. It shouldn't have any problem. And you can always run snapshots and then return to your snapshot. That's basically what I always do when I analyze malware samples of when I run code I don't trust. Well, in this case, it's my own source code, so I trust myself. I wrote the C++ program myself. I don't know why it's behaving like that. The antivirus, but anyway. So let's come back to it. So now it's gonna break here. Let's run it. So close the compiled part of it. So now it's here. It should reach this breakpoint. So we are here. So now what we want to find is the serial because it's asking us for the password. But before reaching that point is I think it's only data count, so basically only pop up this on the screen. But now we have reached the I stream, so now it's waiting for input. It's a input stream, so let's type some A's. Yeah, that's enough. And let's continue to it. And now somewhere here we'll find the amount of A's. So we continue the execution. And now if the amount of A's is correct. So I'm gonna show you manually. So basically going to the whole code, to the whole program, and then I'm gonna show you a clever way of checking this, not only this crack me, but this type of crack me. So now it's constructing it. Now it's calling move, mem copy, mem copy. So now we can see not only our code, but also part of the serial. You see, if I press A, I will show it. It's exploitpack dash. So that's not the full serial code. So basically, it's constructing, it's making the serial code, the serial. So now it's moving it to racks. It's checking for it. This should be our password. This is what we typed in. Yeah, and this is part of the serial. So this is the full one. You can see that it's referencing from buffer one. So buffer one is gonna move the content of RBX, that's the constructed serial, into RCX in order to make the comparison. So here we find it on memory, so we can just copy it. And then it's gonna compare it against the other one. So basically the size, and then the calling many compare. And then continue execution. Now, if we drop the correct serial that we grab it directly from memory, you see that we continue execution here, then the password is correct, it says good job. And now I'm gonna, besides taking it directly from memory when it's making the comparison, let's do some clever ways. So if you look at the DLLs and the functions that this program is using, it's also using memCompare. That is a function to compare memory. So it's comparing it's typically used to compare strings. In this case as well. So here again, like we did with the is about present function, we can add here breakpoint. So let's set a breakpoint there. So first, let's list our breakpoints. Breakpoint list. So we have the conditional breakpoint and the other breakpoint. Remember, we set it here, so we're gonna remove it. So now we only have this conditional breakpoint. The action is none, but it's enabled, so it's gonna continue execution and bypass the is about present. Besides that, we have no breakpoints here. But what we're gonna do, we're gonna go to imports and look at the functions, and then because we found the main comparison, we're gonna follow the reference for it, and we're gonna go into this sham. Because this is from the text section, and without sham, this is the sham that we can set a breakpoint before it goes into the DLL code itself. So we set a breakpoint here. We're gonna run it, and then we're gonna type a password. And then we reach our breakpoint. Now, if we follow this breakpoint, now the program is should stop at the execution here. So we follow it, pressing F7. Now we reach the DLL. We see runtime 140, and this is the offset where we have the main compare function. And inside the main compare function, here is a trick. We can see that is the first two subtractions belongs to first for RCX. Is gonna add to RCX to this registry the serial code, and on the other side, RDX is our input. So that's a clever way of finding quite quick the serial code. So if you find a query that use main compare, then you can do this trick. And you can also write. There is good job. You can also write a script that will look into your QuackMe if you have main compare and then gather those values for you. So that's something that you can have on your arsenal. So basically, if you want to solve a QuackMe quite quick, that's some checks that you can do. Just have the script and then run the script. Okay, guys, thanks for watching this solution. Leave a comment if you like this video and see you in the next one. Bye.